So assume that we are considering an object moving in a straight line where the position of the object as a function of time is given by the function f of t. And we are interested in the average velocity of the object on the time interval from time t1 to time t2. So we will denote the average velocity by v subscript a v e for the velocity average, so the average velocity. So if you recall, the velocity of an object moving in a straight line is given by the change in position, delta f, versus the change in time, delta t. Well, it's clear that the change in time is t2 minus t1. And what is the change in position? Well, let's look at the graph of the position function. At time t1, the y value is simply f of t1. The position at time 1. And the y value at time t2 is, of course, f of t2. So the change in position is the position at t2 minus the position at t1. So f of t2 minus f of t1. And this is how you obtain the average velocity of an object moving in a straight line on a given fixed time interval. Final position minus initial position divided by final time minus initial time. I want to make one last remark, is how can we look at this in a more geometric way? Well, we have these 2 points on the position function as a function of time, so we can connect them with a straight line and form the corresponding right triangle. And if you notice, the base of the triangle, the length is t2 minus t1, delta t. And the height of the triangle is f of t2 minus f of t1, which is delta f, the change in the position of the object. So geometrically, the average velocity of the object on the time interval from t1 to t2 is the ratio of the change in position versus change in time. So it is therefore the slope of the secant line connecting the position function from time t1 to time t2. So this gives you a very geometric way to think of the average velocity of an object moving in a straight line in terms of the slope of the line connecting the 2 points on the position function. And that's it.